All right, good afternoon, you guys. I hope you're doing well today. On our agenda is lessons 54 and 55. Now, I know, is there a test in there? Now I have myself questioning myself. Do we have a test coming up or no? Do we just have a test? Oh goodness, I can't remember my classes now. We just had a test. Okay. I'm not going completely crazy, just a little bit. I'm losing my mind here with everything. All right. So on Monday, what we had focused on then is starting the next unit. Okay, it's coming back to me. I had to get it there. So Monday, we focused on starting our systems of equations. And the first thing I had looked at was graphing more than one. So we had practiced our graphing sum. And then we had practiced our word problems and being able to translate those. Today, we're going to focus on a different way to solve a system, and that is by using elimination. So remember, a system of equations is when we have more than one equation being graphed on a coordinate plane or being looked at. Now, the elimination method, which is what I'm going to teach you today, generally tends to be the most favorite method on how we can solve systems of equations. There are two other ways that we're going to look at in this unit, but this one tends to be people's favorite. This is my 10th year of teaching the elimination method, and I haven't run into a year yet where the majority of the group favors something outside of the elimination method. So today we'll get a lot of good practice with that method and hopefully having you understanding how to solve systems using that. Okay. Again, remember that a system of equations is when you have more than one equation at a time. All right, so we are going to be looking at two equations at a time and being able to solve for the x and the y in those equations. Okay, so the elimination process, eliminate is part of that, and eliminate means to get rid of or remove. So what we're going to do today is we're going to remove one of the variables from our equation. And it depends on the equation on which variable we want to remove, whether it'll be the x or the y. And to remove that, we're going to add our two equations together. Okay, so these four steps right here have to get into your notes. All right, very important so that we can look back at them when needed when solving using the elimination method. All right, so the first thing that we're going to want to do is write our systems so that the terms are aligned. So that means we're going to have the x's lined up on top of each other, we'll have the y's lined up on top of each other, and then we'll have the constants at the end lined up together. The second step after we align those is to eliminate one of the variables. So that's when we would take a look at our system and decide which variable we want to get rid of, whether it's going to be the x or it's going to be the y. The third step after deciding which variable we want to get rid of is to then, well, we have to solve for the first variable, but then we're going to substitute our value that we got in step 2 back into either of the equations and solve for the last variable that's still missing. Okay. And then step 4 is to write our answer as an ordered pair. All of our answers should be written as an ordered pair. Remember, that's x comma y. So we have to make sure it goes in that order. So we always want the X number to come first and then the Y number to come second in our pair. All right, so those 4 steps are really important. I'm going to give you a couple minutes to copy those down. When you have those written down in your notebook, go ahead and give me a green check mark. While you guys are still copying that down, how do you like the background with the snowflakes there? I heard, rumor has it, that possibly, just possibly, this weekend there is a chance for some snow. Now, I don't think it's going to stick by any means, but Saturday I heard there's a possibility. I'm not quite as enthusiastic as some of you guys are. I already got my heated blanket around me. I am not a fan of cold weather by any means. I'm definitely going to be one of those people that move down to like Florida in the winter months because I'm not a fan of the cold. Once my kids are grown and out of the house, Florida, here I come. Oh, now I feel a Frozen song coming on. All right, so let's go ahead and take a look at an example since most of us are done there copying those steps. So step 1 is to make sure that everything is aligned. So when I said everything is aligned, here's what I meant by that. So notice that I have 2 equations here, equation 1 and equation 2. And in my equations, I have it written so the x's are kind of on top of each other. The y's are lined up, and then those numbers at the end. Okay. So step 1 is complete. Everything is aligned with where it should be. So step 2 then is deciding which variable we want to eliminate. Now we need to be very strategic here. So take a look at the x's and take a look at the y's. Now when I add my equations together, which one is going to be easier to get rid of? So if I'm going to be adding these together, which variable is easier to get rid of? Is it the x variable or is it the y variable? We got kind of a mixture here. It's going to be the y. Now I notice that it's going to be the y variable because they have the same number in front, right? They both have a 3. Now what I really want to happen is I want one of those to be a negative and the other one to be a positive. Because if they're the same number and opposite signs, then when I add them together, they go to 0. And that's exactly what I want to happen. I want one of the variables to go to 0 when I add them together. So I have that with the y's. So we are going to eliminate the y's first. Okay? So eliminate the y's. And to do that, we just have to add our equations together because they are already opposites of each other. So let's go ahead and add the equations together. What is 2x plus 5x? That's our 7x, right? The y's, when we add them together, go to 0. We have to have that happening. Negative 3y plus 3y has to go to 0y. So if it goes to 0y, we don't even write it. Okay. And then what is 15 plus 27? A 42. Okay, good. And it is okay to use your calculators here when you're adding because some of the numbers are going to get a little large. So it's always good to verify with a calculator. All right, lastly, we have to solve for x in this equation that's left. Yeah, so Hunter says x equals 6, and he got that because he divided both sides by 7. Okay, so 42 divided by 7 leaves me with my x equaling 6. All right, we have now completed step 2 because we solved for one of the variables, right? We got x equals 6. All right, any questions up to this point? Because we're about halfway done. Okay, step 3 is then to solve for y by substituting this answer back into one of our equations. Now, does it matter which equation we substitute that into, whether it's the first one or the second one? No, it doesn't. So which equation do you guys want to substitute the x back into? Do you want to do it into equation 1, or do you want to do it into equation 2? All right, 2 was the first thing I saw come up in the chat box, so we'll use that. So we're going to do 5 times x, which is our 6, plus 3 times y equals 27. And now that we have that substituted, we need to simplify and then solve for y. So the first thing I'm going to do is my 5 times 6. And what is the 5 times 6? That's our 30. Everything else will just stay the same for right now. All right, what do I need to do from here to try to get the y by itself? Yeah, we need to get rid of this 30 that's in the front. So if it's a positive 30, we want to subtract 30. Now again, be careful with our subtraction. What do we get here? So this is gone. I have a 3y that's left. Yeah, we should get a negative 3 when we subtract. So always be careful of that subtraction. My last step, because it's 3 times y, let's divide by that so that y can be by itself. And what is negative 3 divided by 3? A negative 1. Okay, so step 3 is now complete. You have the other variable solved for, which is your y. Step 4 is to write your final answer. So your final answer should be an ordered pair, which always goes x comma y. So we need to be careful when we write our final answer because sometimes we might actually solve for the y variable first. But when we write our answer, it always has to go x comma y. So x was 6, y was negative 1, so we need to write our answer as the point 6, negative 1. Okay. And this point is going to represent where your 2 lines intersect at. So those 2 lines are intersecting at 6, negative 1. Okay. Now to check your work, because it's always good practice to check your answer, what you would do is you would substitute both the 6 and the negative 1 into both equations and make sure you get true statements. So when you do that, you should get 15 equals 15 and then 27 equals 27. Okay, any questions with that first example? Okay, let's take a look at another one. Unfortunately, things aren't always going to stay that nice for us, but we'll do one more example where it does. Take a look at this system. So you have 2 equations, and my equations are lined up nicely, right? I don't have to move anything around. The x's are on top of each other, the y's are, and the constants are at the end. So looking at our system, which variable are we going to eliminate first? The y's, right? Because if we look at the number in front of them, one's a -4 and one's a +4. That's the best case scenario we can run into, because when we add them together, it will go to 0. All right, so let's add. What is 3x plus 1x? That's our 4x. Notice that the y's go to 0. That's what we wanted to happen. -4y plus 4y is 0. But then what is 10 plus -2? Or 10 minus 2? An 8. All right. From here, we can go ahead and solve for that x in the equation that's left. So if I have 4x equals 8, what should I do to get x by itself? Yeah. You divide, right? And you're going to get x equals 2. All right, we're halfway done. So I'm going to stop. Any questions with how we got this far? Okay, things are going pretty good then. All right, we need to substitute. So do you want to put that back into the equation 1 or equation 2? And again, there's no right or wrong answer there. It's just a preference. Equation 1 this time. All right, so I'm going to find another dark color to write in. If I put it back into equation 1, instead of the x, I'm going to write the 2. 3 times 2 is a 6. Okay, have to let the audio catch up. Then from here, how am I going to solve for my y? Start by subtracting the 6 first, whatever is not attached to the y, right? Let's see, 10 minus 6 is my 4. Good. And then what's my last step? Hunter's already got her answer there, which looks good. Yep, then we divide. +4 divided by a -4 is a -1. Okay, now again, we need to finally write our answer as an ordered pair. So how am I going to write this as an ordered pair? What comes first and what comes second? Two, -1. Very good. All right, any questions with how we got our answer in that second example? And that example went a lot faster, so we were pretty good with that one. Okay, then let's kick it up a notch and let's see what happens or what we have to do if we don't have a variable that adds up to 0. All right, so I'll go back to that slide that I just went over I skipped over it. We'll come back to it in a minute. Take a look at this system. You have 2x plus y equals -5 and 2x minus 5y equals 13. Which variable do you think is easiest to eliminate? Yeah, so Brooke says start with the x. Jessica agrees. So does Emily. All right, but let's take a look at it this time. When I add the equations, will that go to 0? No, it won't, because 2x plus 2x is a 4x. So it doesn't go to a 0x like we wanted. What has to happen for that to go to a 0x like we want? So right now it adds to 4x, but what needs to happen for it to go to a 0x? One of the numbers has to be negative. Now, does it matter which one is negative? No, and that's the nice part. It doesn't matter. So do you want to make the top number negative or the bottom number negative? The bottom. Okay, now it's not that easy. We can't just say, well, I'll put a minus sign in there and we'll call it good, right? I wish we could. But it's not that simple. So to make that a minus sign, what we need to do is technically distribute a -1 through the entire second equation. Now that I'm done sounding like a chipmunk, because the audio froze for a minute, I need to multiply everything in the second equation by -1. So -1 times 2x is a -2x. -1 times -5y is a +5y. And -1 times 13 is a -13. So what basically happens is that we're doing the opposite of everything in equation 2. Right? This one was positive, now it's negative. This was negative, now it's positive. This was positive, now it's negative. By doing that, we can now add our equations together, right? Because now when we add them, this becomes a 0x. These are gone. What is 1y plus 5y? A 6y. And careful, what is -5 plus -13? A -18. Don't miss the negative sign that stays with it. Okay. The last step to get y by itself, if it's 6 times y, let's go ahead and divide still. And what will we get for y? Y will equal a -3. Okay. Now that we've gotten that hard part out of the way, the rest of our process is identical to what we did before. So now let's substitute back into one of our original equations. I usually recommend substituting into the one you didn't change, but that's not always an option and it doesn't really matter. So do you want to substitute into equation 1 or equation 2? All right, equation 2, and I am going to take the original one, but you can also substitute into this equation that you changed. You'll get the same answer no matter what. So I have a 2x minus 5 times y, which I now know is -3, equals 13. Let's clean this up. What is -5 times -3? A +15. Oh, I probably should multiply. I'm sorry. All right, and then to solve for x working backwards, we should subtract 15 from both sides. What is 13 minus 15? Careful, Brooks got it, -2, right? Okay. And then lastly, we can divide. Yeah, so Hunter and Emily are getting a -1 here. So we solve for both variables. We have to write our answer as an ordered pair still. So be careful, because here's an instance where we solved for the y first. But in our answer, how should it be written? Yeah, we want the -1 to come first and the -3 to come second. So it always goes x comma y in your answer. All right, any questions with that one? So that one was slightly more challenging because we did have to multiply our equation by -1 before we could add them. Okay. Let me read through this one real quick. It says, in some cases, you will first need to multiply one or both of your equations by a number so that your variable has opposite coefficients. This is your new step 1. So if I were to go back to this example, we had to multiply this equation by -1 in order for it to cancel. Sometimes we have to actually multiply both equations by something before they cancel. All right, so generally, to give you a hint here on what you should be looking for, I generally look for the equations that have opposite signs. So looking at your variables with the x and the y there, neither of them have the same number in front of them, right? You have a 1x and a -3x. You have a 2y and a 1y. So because neither of those have the same number, then I look to see, are there at least opposites, meaning one's positive and one's negative. Yeah, and Emily said, well, the x's have that, right? I have at least a positive x and a -3x. Okay, so now that at least they're opposites, my goal is to make this top number a 3x, right? Because if I can make that a 3x, then when I add them together, they will go to 0. Okay, but we can't just put a 3 in front of the x. I have to keep it consistent, so I need to multiply everything by 3 in that first equation. So I'll get 3 times x, which is 3x. 3 times 2y, which is a 6y. And 3 times 11, which is a 33. So is everybody okay with how I changed that equation 1 by multiplying everything by 3? Okay. Now the second equation, nothing's going to happen in, because now we have that -3x that we needed. All right, so when I add these together, the x's go to 0. They have been eliminated. Let's see what's left for the y's. What is 6y plus 1y? All right, we get our 7y there. And then what is 33 minus 5? And then to solve for y in this equation, let's divide both sides by 7. What will y equal? Okay. The hardest part is over. So the hardest part of this problem was trying to eliminate one of the variables, and you've done that. So now you have y equals 4. So now our steps go back to like they always have been, and we have to substitute to find x. So do you want to substitute into equation 1 or equation 2? All right, equation 2 it is, so I'm going to use a negative 3x. But instead of saying plus y, I'm going to put in my plus 4 equals negative 5. And now let's work backwards. So we'll start by subtracting 4. So these go to 0. Yep, negative 5 minus 4 is a negative 9. And then let's divide by the number in front of our x still. So negative 9 divided by negative 3 is a positive 3. All right, so how will I write my answer then as an ordered pair? Perfect. 3, comma 4. So always x, comma y. All right, we're getting a little bit more difficult with our examples here. So any questions with this process? Okay, then the next example is the hardest one yet. All right, so in this example, I actually have to do a couple of things. So first of all, we have to decide which variable is going to be easiest to eliminate. And I use easy in air quotes because neither one of them are particularly nice. But there is a better choice in our scenario. Which variable is the better choice to eliminate? The x's. Why are the x's the better choice? They have opposite signs. They're not the same number in front of the x, but neither are the y's, but at least they're opposite signs. Okay, so now that they're not the same number, what is a common multiple of 2 and 5 that I can get to maybe get them to go to 0? So if they're not the same number, 2 and 5, we have to look for the least common multiple. What is the least common multiple between 2 and 5? 10. Good. And everybody see that? Because it goes 2, 4, 6, 8, 10, so forth. 5, 10, 15, and so forth. 10 is the smallest number in both of those lists. So we want to try to get our equations to have a negative 10x and a positive 10x. All right, to get the negative 10x in the first one, what would I have to multiply through by? Negative 5 times what is negative 10? So negative 5 times 2. And we want to make sure it stays a negative, right? Because we don't want to change their signs at all. So we're going to multiply through by a 2. So I'm going to go ahead and do that first. That's going to give me my negative 10x. 2 times 2y is a 4y. And 2 times 32 is a 64. Okay. My second equation, I need a positive 10x to start that multiply by, so that first number is going to be a 10x. To multiply through by a 5, right? Because 5 times 2x is a 10x. 5 times 3y is a 15y. And 5 times 10 is my 50. Okay. This is the hardest example you will ever run into, right? Because you had to multiply both equations by something for a variable to eliminate. So let's finally go ahead and add these together so those x's are gone. So they go to 0. What is 4y plus 15y? And 64 plus 50? $114. All right, we're definitely going to need a calculator here, unless you're really good with your times tables. But we want to divide by 19. What is 114 divided by 19? A 6. All right, I'll stop here. Any questions up to this point? Okay, now you have lots of options because now we have to substitute to find x. You can substitute into your original equation 1 or 2 or your new equation 1 or 2. So which one do you want to substitute into? So old 1 or 2 or new 1 or 2? I generally go with the smaller numbers. So for me, I would probably think old, like this equation right here, the old second one is probably the easiest because the numbers are the smallest. So for me, that's what I look for because I do better with smaller numbers than large. So I would probably substitute into this one. So I would do a 2 times x plus 3 times y, which is now 6, equals 10. And for me, mentally, I can do this in my head, but in one of these other equations, I may have needed a calculator to help me out. So I generally look for the smallest numbers to go for. Okay, what is 3 times 6? Yep, 18. What do we have to do to solve for x in this equation? Start by subtracting that 18 from both sides. So 2x, that's gone. What is 10 minus 18? Ooh, careful. Negative 8, right? And then lastly, it looks like we can divide by 2. What is negative 8 divided by 2? We should get a negative 4. Okay, so then to write our final answer, we got to make it as an ordered pair, x comma y. So we're looking at negative 4, positive 6. Yeah. And like I said, this is the most challenging type of problem that we will run into, where you have to multiply both equations by something. We will continue to practice with this in our live classes from here on out. okay, especially through Unit 5, as this is the more complicated scenario. Okay. But up until this point, were there any questions with our elimination method? Okay. So I have some new steps here for you because we changed the process just slightly. So if you want to add a new step 1, or maybe just make it an asterisk or something in your notes. So as we changed the examples that we went through, sometimes, if necessary, we had to multiply one or both of our equations by a number that will make the coefficients of either our x or y the same or opposite. Okay? And then from there, the steps were the same. All right, so if you don't have any questions, that's all we really had to cover for lessons 54 and 55. Make sure you're going to your book to get more practice problems with these, especially examples where you do have to multiply an equation through by something for your variables to eliminate. And if you have any questions whatsoever, make sure you sign up to office hours to come see me, because I'll gladly help you with these in office hours. All right, but that's all I got for you today. I am going to open the PowerPoint back up. So if you want to go to any of the examples we did and get them down in your notes, you can do so. But I will let you guys go. Have a fantastic rest of your week, and I'll see you guys again next Monday. Bye, everyone.